Now we're going to look at how to find the line of reflection and also how to look at reflectional symmetry. So when you're trying to find the line of reflection, the first thing you want to do is remember that this line is going through the midpoint. It's bisecting the segments connecting the image and the preimage. So find the midpoint of that segment that connects the first point on the preimage to the second point on the image. Then calculate the slope on that same segment. But since it's a perpendicular bisector, you're not going to use that slope. You're going to use the negative reciprocal. That means the flip and change sign. So in this example, I have a point at 1, 8, and that's reflected over a line of symmetry, well, actually a line of reflection, really, and determine the equation of the line of reflection if the image is at negative 1, 2. So the first step I'm going to do is calculate that halfway point between those two, because I know my line has to go through the midpoint. So I add my x1 and x2 and my y1 and y2, and I divide both of those by 2, and I get the point of 0, 5. Then the next thing I need to do is find the slope of that segment, because my line of reflection has to be perpendicular. So I use the slope formula, and I go 2 minus negative 8 and negative 1 minus 1, and I end up with a slope of 3, negative 6 over 2, which is 3. My perpendicular slope is the flip and change sign. Now there's nothing under the 3, but you can actually write a 1 under it. So my new perpendicular slope is 1 over 3 instead of 3 over 1, and it's negative instead of being positive. I'm almost done. Then I use our regular formula that we love, the point slope form. So I have my point, which is the midpoint, and my slope, which is the perpendicular slope, and I substitute those in. Y minus 5 equals negative 1/3 times x minus 0. Well, I distribute the negative 1/3, and negative 1/3 x is negative 1/3 x, but negative 1/3 of 0 is 0. So that term kind of goes away because there's nothing there. Then I can add 5 to both sides. And then finally, I come to our final answer, negative 1/3 x plus 5. So when you're finding the line of reflection, remember you're just finding the perpendicular bisector of the segment that connects the preimage to the image. Now another thing we want to look at is reflectional symmetry. So what does that mean? If the preimage and the image look identical, then it was reflected over a line of symmetry. So I'm going to go ahead and look at this example problem you have. And I have the cool GeoGebra app again. And I created a line of reflection. All right. So this line, my image will go over that. The clear one is my preimage. So I can pick any points on here to make my line of reflection. And you can see, well, I tried connecting those two. Sometimes you have to be a little picky. And let's see if that's my line of reflection. That one should work. No, it's not. All right, maybe I need to go midpoint to midpoint. Whoops, I accidentally moved my object. Go away. Go away. There we go. I'll connect that point to that point. Ah, okay. When I'm going through the center of my object, you can see that the reflection and the original image look the same. So let me see if I can pick this back up and straighten it out. I'm not going through the center anymore. I can fix that. Go right through the center on my line of reflection. Does that work for any of line of reflection? No. You can see here I am going through the center, but that's not working so well. What if I go through here? We'll go through these two corner points. Whoops, let go. Here we go. So I'm going to go through that one and there, cutting through the center. I don't know why my center's not staying the same anymore. There we go. And this point I'm going to hide because it's apparently not behaving. So anyways, you can see there when I cut through the center, when I'm cutting it in half, where both halves look the same, that is reflectional symmetry. I can even go sort of horizontal here, although my image has changed considerably. And you can see that then I made it overlap again. So there are a couple different lines of reflection. There's these going through the center points here, and also going through the center points on these little corners right here so that I cut it in half. Now, why didn't it work there even though I went through the center? Well, I'm kind of cutting it in half, but not exactly the same halves. When I come here, the halves match, so the reflection looks good. Okay? So basically, your lines of symmetry for this problem are going through the center there, kind of cutting in those corners, and then the horizontal and the vertical. So for further reflection, what are the steps to find the line of reflection given a point on the preimage and the image? They are the perpendicular bisector steps. In other words, find the midpoint, find the slope and do negative reciprocal, and do point slope form. You're going to be doing this the whole year, so get used to finding perpendicular bisectors. And then what is reflectional symmetry? When do I have a line of reflectional symmetry?